So we are going to review over everything that you had to watch a video, well, not everything, most of what you had to watch a video on last week, just to make sure you really get it. Please ask me questions if you have questions, okay? I feel like there were some questions last week. I don't know if y'all were just being nice and knew I felt bad or what, but 3.5, which is what you watched the video on Friday, that's actually not on here because that will review itself when we do the next section, if that makes any sense. So I thought it was more important to go over this stuff. And then, so you understand, I said maybe we'd have a longer quiz on this day, but I changed my mind. I still want to do short quizzes. We'll just break them up over days. So we're going to go over everything today, and then you'll have a 3.1, 3.2, 3.4, and then 3.5 on Friday, and we'll do 3.5 tomorrow. Okay? Does that make sense? We good? Okay. All right, here we go. All right, so we did some parent function stuff. Now, the parent function stuff we did at the beginning, it's the same stuff. The transformations are the same ones you started learning in Algebra 1. So that doesn't change. Don't try and make it harder just because they're exponentials or whatever. So it says identify the parent function. All right, so this right here is f of x, so the a part of this. F of x, the parent function, the base is what it is, so it's 4/3. That has to be in parentheses, because if not, when you put the exponent on it, it would only go on the 4, and you want it on the whole thing, right? So it's 4/3 to the x. Now, depending on what the base of this is, changes whether it's increasing or decreasing. Which one is this one? Increasing because it's greater than 1, right? Be careful because it's a fraction. This is greater than 1, so it's...
I thought you know how it looks like.
It is how it looks like.
God, there's a reflector of the x-axis.
Oh, no, I'm talking parent function. Yeah, okay, I see. Okay, yeah. No, and not what this looks like, the parent function, because you're right. Okay, so you were thinking right. I know I'm right. Okay. Woo, confidence today. Okay. Hey, it's good to be confident. All right, so now we look at this, and how many transformations are there? 4. You should always think about that first, because sometimes you forget things because you go through and you think you've hit everything. There's 4. There's the negative, the 2, the 3, and the 1. So I'm going to make 4 little dots, so you don't always have to do I do that, so I make sure I actually do 4, so I don't get distracted. Then I start left to right, that way I hopefully don't mess anything up. So this negative, does this negative affect the x or the y in the equation? It affects the y, but it's a reflection. That's okay, you might be answering a different question. So it's a reflection in what? X, okay? So since it affects y, if it affected x, it would be up here. It affects y, so it's a reflection in x-axis. Right? That makes sense? That hasn't changed. Same deal. Is the 4/3 part of a transformation? No. So I move on to the 2. Does the 2 affect x or y? X. So it is a horizontal something. Is it a stretch or a compression? Compression by what? 1/2. Because x is a liar, he's still a liar. So then I move on to the 3. Does that affect x or y? X. So that means, again, that is x. So that's a horizontal translation. Am I going left or right? Right. So I go right 3. And what does the 1 mean I do? Up 1. Do we agree with that? Yes? Okay. So let's move on to number 5. The a part, my parent function, it's f of x equals, what's the base of the exponent? 7 to the x power. So is this increasing or decreasing? Increasing. Okay. For my parent function, right? It may be different for the actual transformations. Then how many transformations do I have? 2. Sure about that?
Is it 3?
Okay, first of all, is the 7 a transformation?
No.
No, okay. So I have the negative, the 3/2, and the 3. So there's 3. Okay, so the b part, he led you astray. Okay, so we know the 7 is not a transformation. That negative, does it affect x or y? X, which means it's a reflection in y. Very good. All right. Then the 3/2, that clearly affects x. It's being multiplied. So it's a horizontal, either a stretch or a compression. Which one is it? Compression, because it's greater than 1, x lies, so I have to use the reciprocal, right? So that means it is a horizontal compression by what? 2/3, exactly. It's the reciprocal, just like I took the reciprocal of 2 and made it 1/2, right? Then that 3 means I do what? Up 3. Very good. Now, this E is, does it change how my transformations work? No, it doesn't. So my parent function is f of x equals e to the x power. Is that increasing or decreasing? Increasing. And then my b, how many transformations do I have? 3. Good. Is that 1/3 a transformation? Yes, because it's not the base of the exponent. Does it affect x or y? Y. So it is a vertical what? Compression. Good, because y is not a liar. Vertical compression by 1/3. All right, that negative. So I'm going to ask the question differently. What is it a reflection in? The y-axis. Okay, good. All right. And then the 9 means I do what? Down 9. Okay. Any questions at all about any of that or how I figured any of it out? All right, then y'all do number 7 on your own. And we'll talk about it, make sure we all really do get it. Is this one increasing or decreasing? Decreasing, good, because this is less than 1. This parent function, because remember, this is just talking about the parent function, this part itself right here. All right, then how many transformations do I have? 2, right? I have this 5, which makes it a vertical what? Stretch, good. Vertical stretch by 5. And then I have this 3, which means I do what? Left 3. Okay. Any questions at all? All right, awesome. Okay, so now let's actually graph some. So I'm going to start off doing basically the same thing, right? My parent function here, what is the base of the exponent? 2. 2 to the x power, and that means that this is what the parent function looks like, but if I have reflections or whatever, it may look different. It's just a parent function. Then how many transformations do I have? 4, because I have the negative, this 2, the 1/3, and the 3, right? It's okay. The negative is a reflection in what? X-axis, okay. This first 2 is what? Vertical stretch, good. Then this second 2 is what? Nothing. It's the base of the exponent, right? It's okay. I know. All right, so then the 1/3, what is that? Horizontal stretch. Horizontal stretch. X is a liar. Horizontal stretch by 3. Oh, and then this 3 means what? Up 3. Okay. I highly suggest, even if you're not required to actually write these out, okay? Because otherwise you might miss something, and I think that's what happens with a lot of people. All right, so my parent function, I know that this point for the parent function, I always have a y-intercept of what? 1, right? Always have a y-intercept of 1 on the parent function. So I'm going to go to 0, 1, and then I'm going to do all my transformations, right? Does that make sense? I'm going to reflect in the x-axis, boom, I end up here. Vertical stretch by 2. So I'm at -1, I go to -2. Horizontal stretch doesn't go anywhere because my x value is 0, and then I go up 1, 2, 3. So I'm like back where I started. But, you know, whatever. Oh, I forgot the most important thing. What should we always graph first?
Asymptote.
The asymptote. I should sketch it. You're right. I should sketch that first, but I should always put the asymptote in there. For my parent function, my asymptote is right here, right? What is the only thing in here that affects my asymptote?
The up 3.
The up 3. So instead of being at y equals 0, I go up 1, 2, 3. That's where my asymptote is. Okay? Even though it's possible to cross horizontal asymptotes, and we know that, is this graph going to cross a horizontal asymptote? No, because it doesn't change the fact that it's an exponential. Like that's a rational thing. Okay, so I did this point. So now, since the base is 2, my other anchor points depend on this base. For the anchor points, if x is 1, that makes this point, the y value 2, right? So I'm going to go to 1, 2, put my pencil there. Then I reflect in the x-axis, end up down here at -2. Vertical stretch by 2, that puts me at -4. Horizontal stretch by 3, my x value is currently 1. I multiply it by 3, it turns into 3. I don't move 3, I go to 3. And then I go up 1, 2, 3. And I'm not back where I started from. Right, that just happened on that one point. So then, back over here to my parent function. One reason it's very important to actually write this part down so you don't get yourself mixed up. If for my parent function, if x is -1, what's the y value? What's 2 to the -1 power? 1/2. 2 to the -1 equals 1/2. So I would go to -1, 1/2. I'm right here. I reflect in the x-axis. I'm right here. Vertical stretch by 2. Current y value is -1/2. I multiply it by 2. I get -1. Horizontal stretch by 3. I'm at -1. That becomes -3. And then I go up 1, 2, 3. Those are my 3 points. So I should have an idea of what's happening with my asymptote and whatnot. And it looks like this. Okay, I'll give you a second to figure out what you did. Things are weird. What questions do you have? Everybody good with where everything came from? Do I need to walk you through it again on any of them? Okay. All right, so let's fill this stuff in over here. The domain, it's -infinity to infinity, right? It's going to be that for all of them. The range changes, though. Good. -infinity to 3. I never include the infinities. Do I include 3? No, because I never actually make it there. My y-intercept is 0, 1. My asymptote, y equals 3. Is it increasing at all? No. It's decreasing the entire time, so it's from -infinity to infinity. And then my end behavior, as x approaches infinity, what does f of x approach? -infinity. As x approaches -infinity, f of x approaches? 3. Okay, and I want to make a little note about my graph. Now, I'm not going to be crazy picky about this stuff. I just want to make sure that you understand if you're doing it in delta math, why you might get something wrong. If I graphed it and my graph looked like this in delta math, it would probably count it wrong. Not because any of this is wrong or my asymptote is wrong, but do you see how when it goes up here and then it goes down a little bit? That's not really what's happening, right? It's supposed to be getting closer and closer to it. So I wouldn't count that wrong on your paper, because if you clearly, unless you made it go like this, which I've seen some people do, but just be careful with that. And sometimes I know it's kind of hard to make it do that, but kind of like the other thing where y'all have made it, some people were making it hook back and then it wasn't a function. It's little things like that that sometimes you don't realize that is happening when you're graphing it. So, all right, let's look at the next one. So the next one has E. So I need my estimations, right? Basic, broad estimations. But I'm first going to do my parent function. So f of x equals e to the x, and that is increasing. How many transformations do I have? 3. So I have that 1/2 means that's a what? Vertical compression by 1/2, because y doesn't lie. That negative is a reflection in what?
Y.
Y-axis, good. And that -1 means?
Down 1.
Down 1. All right. So the first thing I want to do is put in my asymptote. Thank you very much. Where is my asymptote? -1. So I'm going to go ahead and write it over here too. Y equals -1. And I will sketch that in. Okay, beautiful. Then I'm going to, is this still 0, 1 for my parent function? Yep, sure is. So I'm going to go to 0, 1. I have a vertical compression by 1/2, so I go to 1/2. I reflect in the y-axis, which makes me go nowhere because I'm on the y-axis. And then I go down 1, so I'm right here. Which tells me my y-intercept is 0, -1/2, right? Ask me a question.
You had said you were vertical compression, which is 1/2, and then when you said reflect, you were on the y-axis. So,
Yes, so I didn't reflect, I just went down 1. It looks like I reflected in the x-axis. So, okay, so let me do that again. So I'm here at 0, 1, right? Vertical compression by 1/2, so I end up at 0, 1/2, right? My reflecting in the y-axis, since I'm on the y-axis, I don't reflect. Does that make sense? Okay, you're fine. That's fine. That's why I want you to ask. And then I go down 1, so I end up there. Okay, we good now? All right, good deal. Yeah, if you got a question, ask it. Maybe I did it wrong, maybe I said it wrong, or maybe you got it mixed up. Either way, we got to fix it, right? Okay, so then I'm going to go, for my parent function, if x is 1, what is y about? No, because what is about the estimation of E? 2 point something, something, something. Is it more or less than 2.5? More. It's like 2.7, 2.8, right? So it's like almost, it's between 2.5 and 3, which is good enough on here, right? I mean, it's to get an estimation. All right, so I start off at 1, and then at like 2.78, 2.8, right here. So I'm right here. Vertical compression by 1/2. Well, I'd rather think of it as 2.8 instead of 2.7, so I can make it 1.4. Make sense? So I'm going to go to 1.4 because it's a vertical compression by 1/2, right? Reflect in the y-axis. This time I do reflect, and then I go down 1 to about right there. We good with that? Do I need to do that again? Are you sure? Okay. Oh, you're good. But the look on your face made me question. Are we all good? All right. So then if x is -1, the reciprocal of E is about what?
1 over.
It's like, it is 1 over E. It's about 0.38. 0.4 is probably a good estimation, right? Okay. So those are things that you have to know. Like, you don't have to know the actual decimal. You don't have to, but you know, you need to have an estimation. So we'll go about 0.4. So I'm going to go to -1 about 0.4, which is kind of where that point is anyway. I have a vertical compression by 1/2, which makes it at like 0.2. Reflect in the y-axis, it's right here. Go down 1, I'm right here. Is that enough to graph in my graph? I hope so too. It is. And I realize that you have a calculator there to help you with, you know, E and the reciprocal of E. If you need to for right now to figure out what it is, whatever, but exactly. So 2.718, so that's why like I used 2.8 so I could get 1.4, it'd be a little easier because it really, you can't get that close on here. And then you can do 1 divided by E. Yeah. And it's 0.367, so 0.4-ish. Good enough for the graphs. Okay, we good? Now, domain, it's still -infinity to infinity like it will be on all of them. My range, I start where? -1. Go to infinity. I don't include either one of them, right? Is this increasing anywhere? No. So I'm decreasing from -infinity to infinity. In behavior, as x approaches infinity, f of x approaches -1. As x approaches -infinity, f of x approaches infinity. Okay. We good? So this front part here, that's what your quiz tomorrow is over, right? What questions do you have? We can all do this. We're good, right? The transformations are the same, so don't make up math and you'll be fine. Okie dokie. So let's flip this over. So we're doing exponential growth and decay. So let's put our first little equation up here. F of x equals a times 1, and it can be plus or minus r, right, to the t power. T is time, r is rate, a is your initial amount. I put f of x, that really should be what? F of t, because I don't have an x in there. Unless I made that x, but you know, those things need to make sense there. All right, so the directions, I didn't even copy and paste directions on here, but it said to set up a function, then evaluate the function. So I want to make sure you understand the two different things with that. We want a generic one that doesn't answer the 14 years part, like that I could use for any years. So I'm going to start with just an f of t type of situation. So it says Jennifer started working at her job earning $6.25 per hour. Every 6 months, she gets a 3.25% raise. If Jennifer has worked at her job for 14 years, what is her new hourly rate? All right, so A is that initial amount. She started making $6.25. Then I'm going to have 1. Is it going to be plus or minus? Plus, because it's increasing. It's increasing by 3.25%. So what's the decimal that goes in here? 0.325. Good. And then to the t power. That is your generic function, right? That's you writing the function. Then we evaluate the function by actually substituting something in for t. T generically is the time in years, right? Or like how many times a year type of thing it has. If it's every 6 months, or how many times, it's how many times it increases, basically. If it happens every 6 months and she's there for 14 years, what is t going to be? 28, because it happens twice a year.
Oh.
So if it happens twice, it's how many times it's going to increase. It's going to increase 28 times over the 14 years. So that means I want f of 28. That's going to equal 6.25 times, and then I can go ahead and add those together, 1.0325, or I could leave it as plus, it doesn't really matter, to the 28 power. And then type all that in. And so because we haven't done a whole lot of decimal stuff yet, for AP, math AP, well, calculus AP, because for statistics it's different. And it's different in your sciences too. I don't know why we can't all agree, but either way. Everything should be correct to 3 decimal places unless you're told otherwise, or it doesn't make any sense. I mean, if this is money, how many decimal places should you be correct to? 2. And I'm pretty sure in the video for these notes that you watched, I made a big deal about you have to write the answer as a sentence. I didn't give you room for that because we were just kind of going over it. So we're just going to put the answer, and it is $15 and what? 30 cents. Okay. And you see how the exponents work nicely on this calculator too? You put everything up there and you can see exactly what you're typing in, and it's not crazy parentheses. That's how the online calculators I told you could use, they kind of work that way too, but the TIs do not. That's one reason why we don't even bother getting those out anymore. Okay, so let's look at half-life. It has a half-life of 4 days. Write and use an exponential decay function to find the amount of compound remaining from a 75-ounce sample after 3 weeks. All right, so we're going to write the function first. So it's going to be f of t. What is my initial amount? My initial amount, yeah, is 75. You're good. 1, this is decay, so is it plus or minus? Minus. Since it's half-life, what is my decimal? 0.5. Very good. That's what you meant. I know, it's all good. All right, but I don't put it to the t power, because t would be like, in this case up here, it was years been, or it was however many, it wasn't years, it was, because it's not 28 years, but it's how many times it's going to replicate or whatever. So if your half-life is 4 days and t is a day, it's not going to happen every single day, right? So we're going to have to do t divided by what? 4. So you have to decide if you're going to do days or weeks for that. Days makes way more sense to handle this appropriately. So then we have to substitute in now. And what is t going to be? 21. Because if I'm doing days and it's 3 weeks, yeah, wow, that's a throwback. F of 21, it's all good, equals 75 times, and I could leave it 1 minus 0.5 because I'm using a calculator, but that just makes it 0.5. And then 21 over 4. When you go to push buttons on this calculator, when you get to the exponent part, you can put a little fraction in the exponent and do 21 divided by 4 in the exponent. It's another reason that makes it really nice there. And how many decimal places should this be to? 3. Okay, because 3 would make sense here because it's not money. And what do we get? Very good. 1.971, and those are ounces. So at the very least, make sure that we are labeling our answers with the appropriate units, even if there's no room to write a sentence. All right, are we good? What questions do you have? So, good.
Wait, so why is the time divided by 4?
Because it happens every 4 days, and I'm going to have to figure out, for 3 weeks, it's going to be 21 days, but it doesn't happen 21 times. It happens every 4 days over those 21 days. So it's whatever 21 divided by 4 is. Another way to look at it, let's say that it wasn't 21, that it was 20, okay? And it happened every 4 days. You can say, all right, well, over 20 days, and it happens every 4 days, 20 divided by 4 is 5. You could just put 5 up there because it's going to happen 5 times in those 21 days. Does that make sense to you? But since it doesn't divide evenly, it's better just to leave it like that. Okay, that's a good question. Just like here, really, this probably what I should have done up here and you could have done here is 2t, and then t is 14 years. And then when you put that in there, that's where the 28 comes from, and to be kind of consistent. So how you write the equation is kind of whatever, depending on what you want to use for t and the amount of time. Okay, does that make sense to you? Just make sure it, over time what's happening. All right, a 4-foot tree was planted in 2014. A tree grows continuously by 22% each year from this point forward. Find the height of the tree after 8 years. Am I using this equation? What word tells me I'm not? Continuously. Continuously means I'm using E. That's my PERT formula. A equals P times E to the RT power. PERT. So I'm going to write my equation. A equals the principal amount, what we start with. It's a 4-foot tree, times E to the rate is 0.22 times T. That makes sense where everything came from? I mean, these are just formulas. You just got to plug stuff in the right place. So that means that I then get A equals 4 times E to the 0.22 times what? 8. Right? And then you just type that in the calculator exactly like it looks. The E button, y'all find that already? It's over on the far right under the natural log button. How many decimal places should this be? 3. And that should be 23.250. And that 0 is important. What that 0 tells you is that there's more stuff out there. If you divided it out and it gave you exactly 23.25, it's like 23 1/4, then you put 23.25, and that is correct to 3 decimal places. This tells me I rounded and there's more decimals out there, and that is 8. Yes, you round. Here's the deal. I mean, I'm going to be straight up honest with you. I'm going to make you round because you need to know how to round for a lot of things. On the AP exam, whether you rounded or truncated, which means you just chop it off, they'd count it right either way. I tried one year thinking, okay, we're going to truncate because we're big boys and girls. And then it was a hot mess because like sometimes on the SAT you have to round. And I learned very quickly that some of you have no clue how to round. and will swear to me your teacher taught you something that's like a domino effect of rounding, which scares the heck out of me. And I'm like, nah, we need to go back over rounding. Okay. But in the end, on the AP exam, whether it was 4.9 or 5.0, you'd get it right either way. But I'm not going to count it right because you still need to know how to round. Like that's a skill that you need. Make sense? Okay. All right. So then we've got this one. An ice sculpture measures 52 inches and melts continuously. So there's that word again. Continuously means E, by 3% per minute. Okay. And so here with the time, it gave me a year. It has said how many years. So my T was time in years. Here, this time, I'm going to say is in minutes, right? You just make sure that your stuff matches here. So it's my PERT formula. My initial amount, it's 52 inches high, right? Times E, my percent is 3%. What does that look like as a decimal?
0.03.
Okay, 0.03. So I'm just going to put 0.03 because it's too many zeros for me. Negative, though, very good, because it is melting, which means it's decreasing. So that's how you make it decreasing with your PERT formula. Okay, that decimal is negative times T. So there's your initial. That's you writing the equation, and then you can figure it out for however much time you want. In this case, it says 15 minutes. So A equals 52 times e to the negative 0.03 times 15. And what 0.03 times 15 is? Nobody cares. It doesn't matter. Just type it in the calculator like that. Let the calculator do everything. How many decimal places should I have here? 3. So it's 33 point what? 157 inches. All right. What questions do we have? Are we all good on that stuff? That isn't brand new to you, right? I mean, you've seen those formulas before. You've probably done them a few times, actually. But, yeah, they come up again and again, so we'll just go with that. All right. So that's what these first 4 questions on this side, that is what your quiz is going to be over on the next day, Wednesday, whatever the next day is. Okay, so then we're going to do converting from logs to exponents and vice versa. Oh yeah, make sure that when we're doing the calculator stuff up here that you're actually punching it in and if you're not getting these numbers, let me know, because it might just be something, I mean, I know y'all can figure out technology and calculators, but I just want to make sure we're good. Are we good? And you have to put the E, yes. All right, so this first part of this is what your quiz on Thursday is going to be, and we're not done with logs and exponentials for sure. It says we have the logs, we're going to write them in exponential form. Remember that the base of the log is the base of the exponent. So 3 is the base. This is the exponent. So it's 3 to the 3rd power equals, and you keep going around, 27. There's nothing to solve because it's just saying rewriting, right? On number 2, I have a natural log. What is that base? E, because it's a natural log. So e to the x power equals 8. And we don't need to solve it. It's just saying rewriting it, right? Because it's a natural log, so that means the base is e. Good? Good question. All right, so number 3, my base is 49. I take it to this power, the 3/2 power equals 343. Now, we don't have to do this on this one, but just a little side note here. If I wanted to rewrite this with roots, right? What is this 3/2 power? The 1/2 power, that's the same as 3 times 1/2, right? So the 1/2 power makes it a square root. The 3, so it would be like 49 to the 3rd, the square root of that. Or it could be the square root of 49 to the 3rd. It's the same thing either way. Okay? But you don't have to do that there. It's just a little side note. All right, y'all do 4, 5, and 6. And then double check yourself with me. See if we agree. We good? Yes? Awesome. All right. Write each equation in logarithmic, well, let me back up here. 24 to the 1/2, that's like the square root of 24, right? And when you simplify the square root of 24, you can make that 4 and 6. The 6 stays underneath, the 4 comes out as a 2, right? That's what's happening when you simplify. All right, so now we're going to do it the other way. We're going to write it in logarithmic form. So to go the other way, the base of the exponential becomes the base of the log. So this is log base 81 of 9, because you go around in a circle again, of 9 equals 1/2. Right? So here, log base 8 of 1 over 64 equals -2. And this is a little reminder of what happens with negative exponents, right? Negative drops it to the denominator or vice versa. You square it, that's where you get 1 over 64. So this, I don't put log base e. That means it is a natural log. That's a lowercase l, lowercase n of x equals 7. Right? You do the next 3. Unless you have a question. Okay. You don't put the e. Yeah. No, you're fine. Yeah. Yes, exactly. It's like the 10 on the other one. Mm-hmm. Oh, shoot. All right. Do we agree with those? Yes? Awesome. Okay. So now we're going to evaluate each logarithm. That means I should actually have like an answer here this time. So I'm going to set it equal to x so I can set this up correctly. I'm going to have 3 to the x power equals 81. So I'm going to get common bases. I think I'm going to go with 3. So that means that 3 to the x equals 3. So for 81, I got 3 times 3 is 9, times 3 is 27, times 3 is 81. And so if 3 to the x equals 3 to the 4th, then x equals 4. All right, so then here I'm going to set this equal to x. So I have 11 to the x power equals 1. Well, I can't make my common base 11, right? But I can make, well, I guess I can. If I made it 11, I'd have 11x. Oh, no, not 11x. Good Lord. 11 to the x power would equal 11 to the what power? 0, because anything to the 0 power is 1. So x equals 0. And maybe you don't even need to go through this because you remember the rule of the log base anything of 1 has to give you 0 for that very reason. All right, so if I set this equal to x, I'm going to have 64 to the x power equals 256. Can I make 64 my base? No. All right, so could I make 4 my base? So 4 times 4 is 16 times 4, I'm sorry, 4 times 4 is 16, right? Times 4 is 64. Okay, so I can make 4 my base. I was going with the no there. We good with that? All right, so I've got to have 4 to the, but it's not to the x anymore. How many did I have? 3x, good. Equals 4 to the, all right, so I know this gives me 64, 64 times 4. So I get 4 to the 4th. So that means that 3x equals 4 and x equals 4 thirds. All right. So we only have a couple of minutes left. So what I want you to do is I want you to do the last 3 in the last few minutes. And then tomorrow we'll look at those last, like you have enough time to finish them before the bell rings. So do these and then we'll start here tomorrow talking about these before we move on. Okay, we good? Awesome.